Okay, so again, welcome to AP Pre-Calculus, and we're gonna discuss lesson 2.10, and this is all about the inverse of exponential function, which is logarithmic. So let us assign values of x from this exponential function. F of x is equal to 2 to the power of x. We're gonna assign values of x right here. So first value that we're gonna assign is -1, and let's have the function. So everybody please have a calculator, or we'll just take a look right here at this particular point, -1. So what is the function? It's gonna be 0.5 or 1/2, right? 1/2. So 0.5. So the next point, if x is 0, what is y? What is the function?
1.
It's gonna be 1. If x is 1, the function is
2.
2. So we have 2. And if x is 2, the function is
4.
4. And then if x is 3, the function is 8. Okay. Now, by looking at this, we're gonna have to look into the function. This f of x is just equivalent to y, okay? The y. Now look what happens to the y from half to 1 to 2 to 4 to 8. What happens to y? Any noticing? It's being multiplied, right? So
Multiplied by 2.
multiplied by 2. That means we can say that from this particular table, we can identify whether this is exponential or logarithmic. Now look at the value. This is the f of x. That means it's being multiplied. So our conclusion is that since each of this number, according to Jackie, it's being multiplied by 2, right? So once this is being multiplied, then we say that this is an exponential function. Clear, guys? Now, and we're gonna have to take a look on logarithm. We all know that the inverse of exponential function is logarithmic function, right? The logarithm. Therefore, what we do last time for the inverse of the function is we switch x and y. Do you hear me, guys? We switch x and y. So therefore, we're gonna have to say, if we switch this becomes now 0.5, and then 1, 2, 4, and then 8. And you have this as -1, 0, and then 1, 2, and 3. Okay. Now, I'd like you to look at this first. What was our conclusion right here? If the f of x or the y right here is being multiplied, then our conclusion that this is exponential. Okay? Exponential. Okay. But for logarithmic right here, you look at the x values. Where do you think is the multiplication occur? Is it in the x or in the y? It's in the x, right? This one. So therefore, this is being multiplied right here. So we can say that this is logarithmic. Okay? That's how we identify whether from the table whether it is exponential or logarithm. There, guys. Makes sense, right? Okay. So, of course, if we take the inverse of this is an exponential graph, and we want a logarithmic graph. How it looks like. If this is -1 and then half, then the inverse would be half and then -1. Okay. I'm gonna use red color to graph this. So where is -1? um so -1 and then half, so that means half, and then x is 1/2, and then y is -1. What do you think? Is this half this one right here? Because this is 2, therefore this is 1, so half is this, and then we have -1. Okay, so 1 2 1 2 -1. Please check, guys, if I have this right. Is that half and -1?
Yes.
Okay. And what's next? 0 1. So therefore the inverse would be 1 0. So where is 1 0? Is this the one?
Yes.
Okay. And then what's next? 1 2. The inverse would be
2 1.
2 1. So 2 1. And then what's next? 2 4. So the inverse would be 4 2. Okay, we're gonna extend this one. This is 3, and then let's just approximate that 4 is right here, and then 4 2. So right here. Okay, next, the last one is 3 8, therefore it's gonna be 8 3. So let's just approximate 8 3. So this is 4 5 6 7 8, then 3 right here. Let's just estimate, okay? And then you connect all these points, and I have this, you're gonna have this graph. Okay, so which means this is being reflected right here on the other side, and we have line of symmetry. What is our line of symmetry? Y equals x, right? Y equals x. Remember last time? We're gonna have the line of symmetry right here. That's our line of symmetry, wherein we have y equals x. Any question, guys? Again, let us sum this up. To sum it up, once you see in the y right here, which is being multiplied, how about addition, Mr. Roy? Can we say addition? No, because it says multiplication only. Okay, multiplication. So half times 2 is 1. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. Once it occurs right here at the y value, or the f of x, that means this table represents exponential. Okay, while right here the multiplication occurs on the x. Right here the y, and then right here is x. Once the multiplication occurs in the x, it is what? Logarithmic function. Okay, logarithmic. So this is how to distinguish whether from the given table it is exponential or logarithmic. Okay, can I move this up? Is this clear? Okay.
Why is y equal to x?
That is the line of symmetry, symmetrical. Remember, if we do reflection, remember topic 2.8, the one that we discussed last time, the inverse of the function. We switch x and y into y equals x, and then the line of symmetry is y equals x. Okay, so can I move this up now? So we're gonna have big idea right here. The graphs are a reflection across the function. So the graphs are a reflection. A while ago, the graph, the red and the black graph a while ago, So, the domain of the exponential function is the range of the logarithmic function. So, the domain, what is domain, guys? X, right? So, the domain of the exponential function, so the domain is X, sorry. The domain of exponential function is the range of logarithmic function. So we say X and then the Y, and this means the Y so the domain of the exponential function is the range. So I'll just put the domain right here, domain X and then Y, okay, of the logarithmic function is the range of the logarithmic function, and the range of the exponential function, the Y right here, okay, the range, which means the Y is the Y, or the range of the exponential function is the domain of the logarithmic function. The operations undo each other like multiplications and division. So we have the f of g of x is equal to g of f of x. That means to undo this one, that means if the result of this is equal to x, and the result of f of g of x is also equal to the result of g of f of x, which is x, that means our conclusion that these two functions are inverses. So it has an inverse, okay? Now, let us describe the function f of x as exponential or logarithmic, and then find the points for its inverses. Now, what did I say a while ago? For us to determine in the table whether it is exponential or logarithmic, we can say exponential if the multiplication occurs where? At the y, right? At the y. And then we can say logarithmic if the multiplication occurs at the x values. Look at this. Is this multiplication right here? Where do you think is the multiplication occurs? Is it in the x or in the f of x? F of x. So what's our conclusion for this one? Exponential. Okay, this table is an exponential. Okay, how about the other one? Example number 2. Where do you think is the multiplication occurs? From 1/4 to 1, then that means times 4, right? 1/4 times 4 is 1. 1 times 4 is 4. 4 times 4 is 16. And then 16 times 4 is 64. So it occurs right here in the x. So what do you think is this function? This is logarithmic function. So can you write down that this is exponential function? Exponential. And what's the reason why this is exponential? Can you write down the reason? Because what? Is it the x or the y? The y is being multiplied. Okay? Can you write down the reason by yourself? And then that means we take the inverse of this. What's the inverse now? Can you fill up the inverse right here? So you're gonna switch, right? Do I have to show you? Can you manage yourself, guys?
Yes.
To take the inverse of this now. Okay? Could anyone write down the inverse? Any volunteer? Jackie. Okay, shall we give Jackie a round of applause? Okay, how about example number 2? Is example number 2 exponential or logarithmic?
Logarithm.
Why? Why do you think that this is logarithmic? Because
The x is being
the x values right here is being multiplied. So, can you write down example number 2 as logarithmic function, okay? From this table, this is logarithmic because the multiplication occurs at the values of x. Andrea, can you take the inverse of this? Take the inverse of this. Fill up the table.
okay.
Shall we give Andrea a round of applause? Okay. Okay. Thank you, Andrea. Again, a round of applause to Andrea. Any question, guys? Once the multiplication occurs, guys, look at this. 1/3 times 3. What is 1/3 times 3? 1, right? Then 1 times 3 is gonna be 3. And then 3 times 3 is 9. And then 9 times 3 is 27. So the multiplication occurs right here at the y value. Therefore, it is exponential. While example number 2, the multiplication occurs right here on the x. And we can say that what kind of function is this? This is logarithmic function. Can you write down the word logarithmic function for this one? And write down also the reason why this is logarithmic. And you know the reason, right? Because
The x
the multiplication occurs at where?
and the x.
On the x. Okay. So from 1/4 to 1, that means 1/4 times 4 is 1. 1 times 4 is 4. 4 times 4 is 16. 16 times 4 is 64. So, are we clear now? For us to determine whether from the table it is exponential or logarithm. Okay, can I move this up now? So remember, a while ago it says the f of g of x equals g of f of x and can be undo. We undo that one. That means whatever is the result of f of g of x, the result must be equal to x. Okay? To undo this one, the f of g of x should be equal to x. Likewise, the result of g of f of x must be also equal to x. Okay? So remember a while ago it says f of g of x is equal to g of f of x is equal to x. Okay? So if we do f of g of x must be x, and if we do g of f of x must be x also. So for these two to become inverse of each other, the result must always be an x. Otherwise, if the result is not x, then it's not inverse. Let us say the result is 3x equals 3x, so it's not inverse, because we have to be with the definition that to undo this one we must arrive with x. Okay, so to undo this one, we know that this is exponential, right? So that means, what is the base of this? The base is 2. Therefore, we can do log of 2 to the power of, so log of 2 to the power of x base 2. Because the base right here is 2, right? So, again, definition of logarithm. In algebra 2, log of a to the base a is equivalent to, this entire thing is equivalent to 1, right? 1. Therefore, this 1, log of 2 to the base 2 is 1. 1 times x. 1 times x equals x, right? So, this is equal to x. Does it follow with the definition?
Yes.
Okay. Next. Given log of x base 2, so we can also say 2 log of 2 to the power of now what is our x? Remember, for logarithm 2 to the power of x, and this is now our x right here, log of 2 log of x to the base 2. But by definition again, what is this? Equivalent to 1. So 1 times x is equal to x. So are the following functions inverse of each other? Are they inverse of each other? Yes or no?
Yes.
Yes. Okay? So in other words, a while ago, we have thus f of g of x, this one, is equal to g of f of x is equal to x. Next, we're gonna find the inverse of each of the following. Given f of x is equal to 3 log of x base 5. Remember, if we do inverse, what we do a while ago in topic 2.8, we switch the x into y and y into x. Still remember that? Okay? Remember that? So, can I move this up first? So what we do with f of x, we are rewriting what is f of x equivalent to. We are rewriting f of x. What do you mean by this? This is now the y, right? So this is the y. So f of x is written as y. Then 3 log of x base 5. That's the first one. That's the first thing that we do. We are rewriting the f of x into y. And then what's next? If we do inverse, we switch now. What are we trying to switch? The x into y and the y into x. Okay. So this becomes now x and then log of y base 5. And then after we switch, are we solving for x or y?
What?
The y. Very good. Okay, so what we do, in order to isolate the 3, what we do with this 3, we are dividing both sides by 3. So divide this by 3, divide this by 3. So therefore, right here on the right side, 3 over 3 is equal to 1. Or just cancel that. Okay. So, can I continue here? X over 3 is equal to log of y to the base 5. What is the base again? The base is 5. Therefore, we're gonna move this right here. Rewriting this into, since 5 is the base, so you have 5 to the power of x over 3 is equal to we have, since the base is 5, so this is equal to 5 log of y to the base 5. Okay, so but what is log of y base 5? 5 to the power of log of y to the base 5. What is this equivalent to? That is equivalent to 1, right? That means 1 times y is just y. So on the right side is just y. So we have 5 to the power of x over 3 is equal to y. So this is now the inverse. So rewriting this one, this is now the inverse, which is the inverse of x is equal to 5 to the power of x over 3. And this is the final answer for example number 3. Okay? Okay, moving on to number 4. Can I delete number 3? Because this solution for number 3 overlaps and we don't have space for number 4. You guys done? Okay. So, what we do first for number 4, this f of x. What is f of x? Equivalent to what we do a while ago in number 3. We are rewriting, right? Okay, so we rewrite this into y equals 10 to the power of x over 6. We're done rewriting. Then what's our next concern? What's our next concern, Julia? After we rewrite, so we're gonna switch now y into x and x into y. So we have x is equal to 10 to the power of y over 6. And what we do next? We're going to take the logarithm of both sides, okay? We're gonna take the logarithm of both sides. What is the base of this? 10. Therefore, we're gonna say log of x. Now we say log of x. Mr. Roy, the base is 10. Are we also consider this as base of 10 without writing 10? But for the sake of discussion, I'll put 10. Base 10. Why base 10, Mr. Roy? This is, what is this one? This is base, right? In order to eliminate that, we're gonna have to say log of 10 to the base, or log of 10 to the power of y over 6. And this is understood to be base 10. Okay? But what is this equivalent to? What is that equivalent to? equivalent to 1, right? Okay. So this is equivalent to 1. Okay, what's next, guys? Do we have enough time? How much time is left? 1 minute. Okay. So, can we continue this tomorrow? Thank you, guys.